Hello everybody, my name is Ibraheem Al-Dhamari and today I'm going to show you how to do Cochlea image registration using 3D Slicer, the stable version 4.8.1 and our 3D Slicer plugin with some tools Cochlea registration. So first of all we need to download some datasets. Let's go to Data Store. And here we can search for some Cochlea images. I already uploaded 3 images of a patient. So this is Cochlea MRI and these are 2 CBCT. This one and this one are images before the surgery, the Cochlea implant surgery, and this one after the Cochlea implant surgery. So we download these 3 images. I just click here, download and load. Then we download the second image and download the third image. Actually I already downloaded them, so they are now just loaded from the cache. If you do this for the first time, it will take few seconds or a few minutes. Now one important thing I usually do is click on here to open the Python interactor, so I can see what is happening during my plugin when my plugin works. Okay, now we can go to Vision Tools, Cochlea Registration, and here the plugin is loaded. One important thing about the registration that it uses elastic binaries, and for elastic you need to have a file name and a path that is legal for it, so it shouldn't have some spaces or some special character. And usually when you download images from that data store, they are saved in TMP folder if you have Linux, for example. And as you can see, there are some special characters here. So what I'm gonna do is resave them in my document. So if you click save, they will be saved there. I already saved them before, so I will not do this now. So I'll just close the scene and load them from my documents. Okay, let's start with 2 images. I'll register this image and this image. So what are these images? From the file name, for example, L means left the side of the ear and DV means CBCT. And the B is for before and A after. So this after is actually after the implant, after the Cochlea implant surgery. So what we're gonna do, for example, we're gonna register the after with the implant to the before. What you need to do is locate the cochlea in the fixed and the moving image. So you click here, then you click anywhere inside the cochlea. So you can recognize the cochlea by its spiral shape. So I just click anywhere inside. It shouldn't be very accurate, just any point inside the cochlea is enough. This point is used for cropping the area around the cochlea. So actually what we are doing is we are registering the cropped images, a small version of this big image, then we use the transform to transform the original images. So now when I click run, we get the result of the transformation in just less than 5 seconds. It's pretty fast, and also it's pretty good. As you can see here, this is the cochlea. You can see this implant here, and this area, for example, you don't see the bone from the image after the surgery because the bone is already removed. You can check also, if you go here, you can see both of the images. So this is before the surgery, you can see the bone, and this is after the surgery without the bone, and the cochlea part is registered successfully. So this is an example. Another example, we're gonna register the other MRI with one of the CBCT. So I take this one and I will register it to the cochlea B4. Just drag and drop. And we will register the B4 surgery to the MRI image. If you want to see, you can now click on the fixed image. This is the MRI. Since we are registering the left side, so we need to click here in the left side cochlea. This image actually has, as you can see, has both sides of the ear. Then we click also here. Then click on registration, and you can see it took less than 3 seconds to register the two images. And the registration is pretty good. You can see the cochlea part is here. And you can see the MRI, soft tissues, and the bones from both images. You can go here also to check each image alone. So this is the cochlea, this part, and you can see the cochlea also in the other images, and they are registered very nicely. So this is about the cochlea. Let's go check some folders. So if you go to the VisSim tools, the output, you can see all the output files and the logs from Lisseck and Transformix, and the transform parameter, the results. If you go to VisSim tools folder and the parameter, you can see the parameter file we are used. Actually, I already opened it, so it is already here. Okay, let's open it again. No, it is already open. Sorry for that. Now, if you see here, the most important parameters are these ones here. So we are using linear interpreter, we are using this adaptive stochastic gradient descent, and we are registering using 3D rigid transform, Euler transform, and with Moschel information metric. These are parameters for the Moschel information, and this one is the number of iteration for the optimizer, and this is also the maximum step length and the special samples for the optimizer, and new sample every iteration, random coordinate. We are using taking samples randomly, and each iteration we take new samples, not the old one. Okay, so these are the important parameters that provide these good results. And if you go to VisSim tools, you can find the parameters and the output results here. Thank you for watching. And one important thing before I forgot, if you have a problem with this plugin or some error messages, please try first to use this command here. So what you need to do is try this one in the terminal, for example, and see what's the result, because this is actually what's happening. The plugin uses this line here in the background. So if this runs successfully, you will get some results in the output folder. You can delete everything in the output folder and try to run this in the terminal and see what will happen. If you get a result, then this is good. If not, then we try to solve the problem with Elastic first. Okay, thank you for listening, and see you next time.